Oh, welcome everyone to the 31st Sonification World Chat and the GeoSonNet project. We are going to have a great couple of presentations today, and I am getting the hang of juggling time zones and changing times. So just in case you guys didn't know that United States and Europe change time zones, daylight savings, they do things at very different times. So it's time zone chaos between March and April. So, but we have it figured out. I think I've got everybody here. And let's go ahead and do some introductions. You guys know me, I'm Kate, and I have been hosting the World Chat for 5 years. Yeah. So, let's pass it to Amy, our fearless leader from Woods Hole. And you are muted, Amy.
There we go. Okay. It's a toggle and I never know which I am. So hello, everybody. I'm Amy Bauer. I'm an oceanographer at Woods Hole Oceanographic Institution in Massachusetts. I'm a blind scientist that has been getting more and more interested in data sonification for my own research and as an outreach modality for the past several years, I guess. Maybe, 2018, 7, 8 years. We had a short pilot project called Accessible Oceans, where we took some ocean data and made some kind of podcast-like auditory displays, and with that team. And we've proposed something else. Who knows whether it'll get by the accessibility filters in Washington, D.C. or not. But anyway, it's under review. So I hope. That's me.
You are muted now as well.
Sorry, Anna, we'll go to you. I keep muting because coughing is in the lineup for me today. So Anna, you get to go.
All right. Hi, everyone. I'm Anna Pinkney. I'm a research assistant at Woods Hole Oceanographic Institution, working with Amy on those same projects that she just mentioned. Nice to see you all.
Yeah, good to see you here. She's my only follower on the posts to the AGU conversations, but we'll keep trying. Let's go over Bruce.
Hello, good afternoon. I'm Bruce Walker. I'm a professor at Georgia Tech with a joint appointment in psychology and computer science. And I wear a lot of hats, including director of the Sonification Lab. I've been doing this for a long, long time. And also, perhaps of interest here is our new Center for Inclusive Climate Communications. Amy is a partner in that effort, as are several of you, I think. So good to see you all.
Hi, thanks, Bruce. And we really appreciate Bruce being on double meetings today. Usually that's Adrian's role. Steve, go ahead and introduce yourself.
Well, I'm Steve Everett, and I am one of the evaluators helping out Kate and the Sonification World Chat. If at any point along the way we determine we need some questionnaires developed or any other kind of data collection tools, I'm going to help with that. And I am not a sonification person, but I was a musician for a number of years, and I found this morning's conversation very, very interesting just from the musical perspective. So I'm hooked.
That's excellent. Kathy, go ahead.
Unmute, Kathy.
Hello. I work with Steve with the Everett Group on evaluation and whatever he tells me to do, basically.
Yep, I consider myself the sonification den mother, so yes, we need to all stay organized. Although you'll hear from Aura later, and I think she's got me beat in that department. But we're going to go to Cheryl next.
Hello, everyone. Cheryl Fogelhatch. I'm a museum accessibility consultant. My firm is Museum Senses. My main focus is tactile media, but I do monitor sonification and help people with it where it makes sense for their content.
And I want to thank Cheryl, along with Gary Ferran, who helped take a look at the at the Zoom website and give some assessments on how, because they give you all the bells and whistles when you record onto the cloud, and are those actually accessible? And we did pretty well. There's a few glitchy pieces, but it was really fun to shadow Cheryl as she went through that a couple weeks ago and watch somebody who's really fluent with her screen reader. I've been working with kids a lot. They're not that great yet, so it takes a lot of practice. Robert, go ahead.
Howdy, Robert Alexander here. About a decade ago, I finished a PhD with a focus on the audification of heliospheric data sets for time series analysis. Since then, I've been working in various capacities. I see Christina Collins on this call. We've worked together on the HARP Citizen Science Project. I've been a data sonification specialist there. I've been working with NASA Goddard Space Flight Center on contract closely with Dr. Jay Verniero, and we're assessing the heliospheric current sheet and other complexities of the solar wind through audification. And then I just presented to NOAA through the contact from this meeting, actually, some work with proposed real-time solar wind radio. So just wearing a bunch of different hats these days.
Well, that's really great to hear that we're paying off for people in the networking department, because that's really what I want to see, because lots of progress gets made with a good network. So Christina, go ahead and introduce yourself.
Yeah, hi, I'm Christina Collins from the Space Science Institute. Good to see familiar faces from ICAD and from our session at AGU this past December. I am currently finishing up a NSF-funded postdoc for sonification, looking at magnetometer data, and started working with Robert as part of that. What I'm really excited about these days is the upcoming integration of sonification into open space. So that's really what I'm particularly interested in. Mike Hartinger, I think, is not able to join us today, but he's also at SSI, and he was PI on the HARP project. So I think people here are probably familiar with that. So excited to hear what folks are working on. Thank you.
Hey, thanks. Thea.
Hi, I'm Thea Damsma. I'm based in Queensland, Australia, on the Gold Coast, where we've just survived a terrible cyclone called Alfred. And we are fine. I'm the director of SonoKids, which is a developer of apps, educational game apps for students who are blind or have low vision. And our apps teach STEM skills, so like coding and how to use devices using the inbuilt screen reader technology. I'm also the co-president of South Pacific Educators in Vision Impairment, which is the professional association of all the specialist teachers vision impairment in Australia, New Zealand, and the Pacific. And I have developed with SonoKids an app, educational app for young children to learn about sonification, where they can just explore how you can use sonification to listen to information like shapes or location kind of things. And I've been working with a teacher and giving workshops on how to integrate sonification in the classroom so that it becomes part of the mainstream curriculum. And I'll be also going to Amsterdam. There's a big conference, Tactile Reading. Is any of you going to Tactile Reading? No. So we'll be introducing sonification there as well.
Thanks, Fia. And yeah, I sent some information off to Fia too, because I been attending a workshop series on tactile graphicacy and the process of teaching tactile and tactile sensitivity. However, and I thought that had a lot of application for the kind of the learning sequence that we could be considering when we look at sonification. So I'm going to continue to attend those workshops and talk to, maybe the Learn group or you all at large later. So I'm going to go over to Aura. I had a great conversation with Aura just yesterday, and I just admire the work that you're doing, and it was very, very cool. So if you could unmute and introduce yourself, that'd be great.
Thank you so much, Kate. Likewise. And thanks for having me here. My name is Aura Wolmer, and I work as a data curator at the University of Michigan, and just been really excited about data sonification for the last couple years, 2 or 3 years. And during the last year, I've been working on a fellowship project to build a data sonification toolkit, primarily geared towards information designers and journalists, but also want it to be accessible and available for anyone interested in sonification. So I've been working on that and just really excited to connect with this community and finally make it to one of these meetings. And I see some familiar faces and names as well too. So glad for that. Thank you.
Thanks. And that, so in April, once I get the time zones all figured out, I'm juggling California and Sweden, but I'd like to see loud numbers, decibels, and Aura's work with her collection and toolkit on for April's GeoSonNet Sonification World Chat, because I think they all go together really well, and particularly with the talks that we've been having with the librarians. I've just been calling them the librarian huddle. Lots of interest from librarians about how they might be of help in promoting sonifications, because they do a lot with visualizations. So more on that some other time, but that's some of the things that are in the works. Scott, thanks for getting here. You want to introduce yourself?
Hey everyone, my name is Scott Fleming. I'm an astrophysicist at the Space Telescope Science Institute in Baltimore, Maryland. My team makes software for the data archives that have about 3.5 petabytes of data from NASA missions, including Hubble and JWST and the upcoming Roman telescope. And in terms of sonification, I also run an open source Python project called Astronify to create sonifications of 1D data sets for research purposes.
Thanks, Scott. And I believe I caught everyone. Speak up now if I failed to do that. Leaf, I'm going to just wait on you till it's time for you to speak. But I'm going to yak for just a minute yet on a few other announcements. The last month was, for like many of you, a bit chaotic. Lots of meetings to figure out where other projects stand. So the amount of, the inefficiencies that got built into rapid change at the federal level was kind of staggering, but we're back on track. And I think that we should be able to catch up on, some of my goals that I wanted to have accomplished here with the GeoSonNet, and pay more attention to transferring some of the things that I'm running into the networking that I'm doing, get that recorded over on the Slack channel, and make sure that people know what's going on a little bit more better. And of course, continuing to recruit, which I can use everybody's help on. So we're also going to get to the point very rapidly where we have to start thinking about the 2025 AGU meeting workshop and what we want that to look like. I'm going to give that another month or so, but just start pondering that, because they are going to have, we'll have to apply for that quite early. So this summer, we'll have to know what we're doing by July, if I have those numbers correct, those dates correct. And then that should about do it for our announcements. And so what we're going to do today is we're going to have Leaf present first, and then we're going to listen to a recording from this morning from Sarah Lindsay's presentation, and Bruce is going to be here to answer questions about the design canvas. We had another presentation this morning, Anita Zanella. I've chosen to pull that one aside and just have that one as a recording to share with all of you after the fact, because most of you, having been part of the Sonification World Chat, are a little more familiar with that work. So that was just a decision that was made. And if we have interest, we will make sure that we get kind of an office hours together if we want to talk more with Anita about her work. So with that, we are going to pivot over to Leaf. And thanks to Amy, I got connected with Leaf at the point at which this grant proposal needed to pivot entirely to the geosciences. And being an astronomy person, I needed to get to know some geoscientists other than Amy really quickly. And I was thrilled to take a dive into Leaf's work and the depth of information that he has managed to sonify, his team has managed to sonify, related to the volcano listening project is really quite impressive. So I'll be I'm really excited to have him here today to talk to you about that project. And then later on, when we hear Sarah Lindsay's project, you've got something to keep in mind about thinking about the design process itself. So, you know, everyone, you know, mute your mics, and we'll save our questions till the end. And Leaf, thanks for joining us.
Great. Can you hear me okay? So far, so good. Okay. All right. Yeah, thanks, Kate, for the nice introduction. And it's really nice. There's a lot of folks here that I don't know and I've never met, so that's wonderful. And this overall feels like a really special space that I hope can grow. Sonification is got a lot of potential, I think, especially in the geosciences. So hopefully this can help realize that potential. I'll just briefly introduce myself again. Here, Leif Karlstrom. I'm an associate professor in the Department of Earth Sciences at the University of Oregon, in Eugene, Oregon. I guess I mostly call myself a volcanologist, although I work on a variety of problems, mostly to do with fluid flow in various contexts, but usually with a volcano angle. I also have a background as a musician. I have a performance degree in violin, and I've had a whole professional career in music in some sense that continues now. And so I kind of have had these two hats that I've worn for most of my life. And it's really the sonification that's where I've found a place to kind of bridge those two worlds in some sense. So that's been a real treat, and has really energized my work in this realm. I should say, actually, you know, the mechanics of being an academic scientist, of course, means that a lot of this stuff is either contingent on funding or is like contingent on my free time. And I have, you know, had some luck, a little bit of luck getting this funded through NSF. But one of the things, as Kate mentioned, and, you know, it's no big deal to mention that here, but I think, you know, a lot of my motivation for being involved in these networks is to like look for the next steps. And I think there's a lot of opportunities here. So I'll just put that out on the table as if folks see things in my presentation or you know, otherwise that are of interest. I'm always interested in talking about proposals and things like this, because that's mechanically how we make progress on these issues, at least for me. So I have a few slides that I've put together that sort of summarize this thing that I've called the Volcano Listening Project, which is really a collaborative effort amongst a number of scientists across different institutions and career stages, that aims to sonify or represent volcanic data through sound, and then also interpret it musically. So there's kind of an aesthetic component as well as a data representation component. So I'll go through those. I'll do my very best to describe them. There's visual elements on these slides, and so if it doesn't seem like I'm doing a very good job at that, please raise your hand or stop me or something like this, and I'm glad to spend more time on this. But with that, let me just jump into a little bit of a slideshow. Oops, wait, sorry. I'm going to make sure that I'm sharing sound. Yes, okay, great. Yeah, sharing sound. All right, and I'm just going to, yeah, I'm gonna just jump into this. So as I mentioned, this is a collaborative effort, and in particular, I guess I want to highlight Ben Holtzman at Columbia, who really, I guess, got me most excited about this. And he's done a lot of work separately. I hope that you invite him to talk separately, actually, because I think he has some very, very good things to say on this topic. I'll just start with this, which is a graph that I put together. This is, you know, not anything fancy, but it's how I view data sort of in a general sense. And it's a graph that has two axes. One of them is labeled representation, and the other is labeled interpretation. And at the origin, right, where the two meet at 0, 0, is like a bunch of ones and zeros. And that's like raw data, right? And as we go to the right along the representation axis, you know, it gets more complicated how we represent those ones and zeros. You get graphs and sketches or videos or 3D printing, things like this. As you go vertically on this graph, you sort of move from raw data into different applications, right? So you can interpret data scientifically, right? And we can learn about the world this way. We can develop technologies. We can, right, interface with society, et cetera. And you go farther up in the interpretation axis, in my view, and it becomes more aesthetic, right? It becomes art, where we're inspired by raw data, but pretty loosely, right? In some sense, like Vivaldi's Four Springs, the Four Seasons, I don't think he was like using data from spring or summer to compose that, as an example, right? But I have plotted on this, sort of different fields: refereed science, outreach, aesthetics, and I guess I sort of view my work as kind of spanning these things, but like in an intentional way, where we're really trying to create things that are aesthetically driven or outreach driven or peer-reviewed science. And so I have some examples, numerous ones. I'm not going to talk about them all, but we do, the musical side of this. There's a link to a record there. There's these data movies, which I'll talk about. There's a link to some of those, and then some more of the technical details, the methods, and this long form blog there. Okay, so that's kind of a guide to what we've been up to. Okay, and I'll just jump into the volcano part of this with the following slide. So again, this is just visual. I promise I have lots of sounds in just a second. But what this slide is showing is sort of a graph of the frequency of seismic data, which is a data set that we collect at volcanoes all over the world. And the instruments that collect this data sample a broad range of frequencies and collects earth vibrations at different frequencies. And they're quite broad bands. And so this graph is showing the range of frequencies in seismic data from log frequency of -4 to 1, so roughly 5 orders of magnitude in frequency. And then right at the top of that, it overlaps very briefly with the range of human hearing, right? 20 hertz to 20 kilohertz or so. And so they're almost distinct. There's a little bit of overlap where you can hear seismic data, but not really. And just to highlight that, then below is a spectrogram, so just showing frequency as a function of time for a big volcanic eruption that happened at Kilauea Summit in 2018. And what's shown on this plot is just a huge richness below the threshold of human hearing, right? All kinds of stuff that's happening and being recorded by the seismometers. And so that's a great target for listening to this data, although we have to get it to the range of human hearing to do so. Okay, I'm going to talk about 3 different types of data here that we commonly encounter in the volcanic world, as probably all branches of science, to be honest. We have direct sonification of oscillatory data. That's things that we can just speed up or slow down to get to the range of human hearing and just listen to it. We then, of course, have time series data, where we have some field that may be varying through time, or maybe a few different fields that are varying through time, and we'd like to listen to that somehow. So we have to make parameter mapping choices, and there's some non-uniqueness issues that I'd like to talk about there. And then finally, I'll talk about event data, where we just have a sequence of things that happen at different times that have certain characteristics, and we'd like to listen to those. So that involves sound design. So I'll talk about that. All right, so 3 things. I want to motivate the first of those, the oscillatory data. This is a video, so again, I'm going to get to the sounds, but just to motivate it, and for those who want to look at pretty pictures of volcanoes, this is a video taken at Kilauea Summit that's showing the lava lake that was active there between 2008 and 2018. And you can see all kinds of activities. A webcam. Below that webcam video, there's a graph with a little ticker going across it that's showing the seismic record that's recorded about 1 kilometer away from the summit. And you can sort of see there's stuff that happens. Rocks fall off, hit the surface of the lava lake, and you see boiling and bubbling. I'm going to skip forward a little bit because what you're about to see is a big rock falling off. Here it goes right now. Yep. Okay. So it causes a big explosion. And then what happens afterwards, you can't really see because of the ash and so forth that obscures the view. But in the seismic record, you can see this sort of beautiful damped harmonic oscillation with a period of about 30 seconds, right? And this is an example of a data set that we think can tell us a lot about the structure of the volcano. There's sort of a resonance happening in the plumbing system. And it's a prime candidate for sonification because, of course, this is sort of like a monochromatic signal that we can listen to, right? And so as an introduction to this sort of direct sonification approach, right, we think this is recording sort of an oscillation of magma in something like this structure here, where there's sort of a tube connected to some sort of subsurface reservoir, and fluid is sloshing up and down after it gets hit by the rock. If we just speed up that seismic data, it takes about 2,000 times to get it to sound pretty good. It sounds like this. Okay, very short, but that's literally just taking the seismic data set and speeding it up by a factor of 1,000. We can do that like that. Okay, and so what I'm showing on the plot are sort of the corresponding models and things we've developed for this. But the sounds, I think, is what I want to focus on. That happened, this particular thing, this rock fall coming off and hitting the surface of the lava lake happens thousands of times over the 10 years between 2008 and 2018. So here's a record I'm showing here, a plot of the period, that dominant oscillation through time. And what I've done in this sonification here is to take a direct approach where we just speed up the waveform, but we recognize that this happens over and over and over throughout a timeline. And so we basically develop a catalog sound approach where we sonify each individual event, snip it out of the seismic record, create a new sound in which we've sort of superimposed these at the relative time of occurrence in a sound of an arbitrary length. So here's 10 years in about, I guess, a minute. And I probably won't play the whole thing just to make sure we stay on time here. But it'll give you a sense of how the dynamics of the volcano evolved over 10 years through these resonant oscillations. Thousands of these events happening. It's just a raw speeding up of the seismic record. And they're tonal, and that's because there's a very clear dominant frequency. The dominant frequency varies through time, and it's telling us about changes in the fluid properties of the geometry of the system, much like an organ. Right? Okay, so another example of this, using a different type of seismic signal, we gathered a bunch of data from the summit of summit of Kilauea volcano during that 2018 eruption that I showed in the first slide, where we want to just listen to all the earthquakes that are happening. And it sounds quite a bit different. It's not tonal anymore because these have a broadband frequency content. But just to give you a sense of what these catalog sounds do. So there's roughly 16,000 earthquakes that we've sonified here. In a minute, the collapse sequence, or the caldera gradually. So there we go. That's direct sonification. And in some sense, I sort of view that as like the easiest one. The choices are pretty clear. We can, oh, let's see. I was told I cannot hear my voice over the data. Sorry about that. I will, I'll try to not make that mistake for the next time. Thanks. So yeah, I guess for the direct sonification approach, it's pretty clear how to listen to the data. We simply speed it up, or in some cases we slow it down until it's in the range of human hearing. But in some cases, right, where we have some parameter that's varying through time, we have to actually make some choices. And there's not a unique way to do that. And I want to highlight 3 different ways that we've explored in the context of one data set. This is a tilt time series. This is basically the tilting of the ground. I think I have a little video of what that is. So the volcano sort of swells up over time, and the tilt meter records the angular displacement, or the swelling of the ground surface. And so this is a data set actually collected at a geyser, but it's sort of the same idea. One method that one might choose for sonifying a data set like this is to choose a frequency range and interpolate the signal onto this range, sampling evenly in time, right? So we sort of draw lines up from the x-axis of time to hit the value of a particular variable that's varying. And you sample it evenly in time, and then you sort of interpolate that onto a frequency range. It might sound something like this. Tilt is going down and then up. that's one example. It's not the only way that we can do this. And of course, we can also superimpose other constraints. For example, we could sample only a particular set of frequencies, perhaps governed by a musical scale, right? And so we've explored this too. So this is, we found that if you don't want to impose biases, it's nice to use a octatonic scale. Oops, somehow I've lost myself here. There it is. Okay, sorry. An octatonic scale that has, a whole step followed by a half step followed by a whole step, etc. It's the most symmetric scale that you can think of. And so you can interpolate only onto those frequencies. And so I'm showing a plot of what that looks like. Again, sort of sampling evenly in time. Actually, no, sorry. The other way that we can do this is that we can choose an even number of pitches, right? We choose a sequence of pitches and then let the change in the data determine their spacing. In this case, right, the rhythm or the sampling of the points in time is not uniform, right? In other words, the rhythm is data driven in this case, rather than hearing the clock being linear in time, so directly mappable from whatever the score time of your sound is to the event time. We're going to let the score time be determined by how fast the data is changing, right? And that's a very different way of approaching sonification, but it's sort of equivalent in some sense. Either you're interpolating onto the frequency axis or interpolating onto the time axis. Here's what that sounds like, same data set. In this case, the note duration is set by the gradient of the data. So faster tilting of the ground in this case gives rise to a faster changing of note. Right? And to me, this sounds a lot more musical, but I'm not sure it's as easy to interpret or as informative because you don't actually know what time is actually happening. It's completely set by the gradient in the data. So, again, depending on what you're after here, it may or may not be the right choice. Okay. So this is the one example here. A third one, the same data set, is where we actually utilize multiple tones to convey the sweeping up and down of the tilt data. In this case, we're again sampling evenly in time, but we're going to basically define a little triangle filter that's sweeping up and down tone clusters, right? And that gives us a chord controlled by the data. And again, a little bit different aesthetic choices, but also brings out other aspects of the data. Here's what it sounds like. The envelope of those sounds then is shown here on the left axis, and it's mapped onto what's being sonified. Right, so just to give you, I guess, 3 different examples here of different ways to approach that sort of time series data. And the third type of example that I want to talk about very briefly is event data. And so I'm going to use here an example of a data set of global volcanic eruptions. This is actually a pretty common data set. It extends thousands of years back in time. I've focused on the last 650 years in this case, roughly the time since the medieval period. And this database basically just includes like when and where did volcanic eruptions occur, as well as what type of volcano was involved, their composition, the magnitude, how much stuff came out, right? And we'd like to convey all that data in an auditory manner, right? So to do so, we have to represent these events by icons, these things, auditory icons or earcons. And so our approach to this is that we basically design a whole bunch of sounds. We build a big lookup table of earcons that we can interpolate our data onto, right? And we're going to use 3 different axes. We're going to have one axis be the loudness of the tone, another be the timbre, which you'll hear in a second, and the third being pitch. And so, with the appropriate key, right, with all of these sounds, when you sort of represent them both auditory and visual, you need a sense of what you're listening to, and you need a key. So with that, and usually with a couple of playbacks, because this is sort of the it blows by pretty quickly if you just listen to it once. You can get a sense of the patterns of volcanic eruptions. through time. Okay, so here we go. This is a video now. It's going to have an auditory and visual component, and there's a key. So I'm going to play that. I don't know if we'll play the whole thing, but you'll get a sense for what it looks like. And so here we go. We're going to start with the key. This is 650 years of volcanic eruption. Okay, and so just to talk through that one more time, what you were listening to in this case was first a scroll through one axis, which is the composition axis at a particular type of volcano and a particular magnitude, and then it swept through different magnitudes at the same volcano, different types of volcanoes, and then finally we sweep through that composition axis at the end. So let's just listen to that key one more time. All right, so and then I do a left-right pan, stereo pan to indicate longitude. So if you're listening on stereo, you should be able to hear sort of where on Earth this is with respect to longitude in terms of left and right panning. I could also say that there's a reference tone being played every 10 years. So there's a kind of a beat that you hear in the background that gives you a sense of absolute time. I'll get through that one. That's simple. I'll just end with, I guess, a plug for this summary that we did. This is a paper that we published last year in EOS, which is an earth science sort of general earth science publication covering a lot of topics at a fairly high level, so without the technical details. And so we sort of made a pitch, I guess, for why we should be listening to our data more broadly rather than looking at it. And so I think it aligns really well with the goals of this group. And I'd be really happy to talk about other possible applications. Yeah, please check out this paper. There's other data movies, stuff that doesn't fit into a short little talk, but happy to talk about it more. So with that, I'll end. Yeah, thanks.
Wow, thanks, Leaf. I also brings out for me the importance of actually knowing how to listen to some of this. You have some very complex stuff, and I know some of it was blowing by. So questions from the group, we have a small group, so just go ahead and unmute and speak up or wave your hand if you prefer I call on you. Whatever you like. I'm keeping an eye open. He's unmuted, go ahead.
Yeah, this is Amy. Thanks, Leaf. That was super interesting. I didn't catch the spatiality of the last one, left, right. Maybe others did. I've got my 2 headphones in, but I didn't catch it all sounded the same. That's just a little feedback. But my real question is how are you using these?
Thanks. Yeah, I probably should have articulated that a little bit better. There's a couple of things I think that we can use them for. I mean, most simply, I think it's an incredible outreach tool and education tool. So I now, having sort of discovered this approach, I use it in my classes every term as a way to illustrate data sets that are sort of complex patterns in time. And I also use this whenever I'm trying to convey my science to a broad audience of any type, whether that's the general public or other scientists. I incorporate these into lectures that I give. I've included them in AGU talks and sort of department seminars and things like this. So I think it's a really great way to engage people in a slightly subversive manner, that it's still not something that's super common, right? To most people, I would say, right? The conveying of data on a graph is something that people expect. Listening to data is not something that most people expect, and so you grab people's attention that way. We've explored the use of these for research, but I guess in the sense mostly, well, two ways, I guess. One is that that geyser example, for example, was a data set that I had collected actually during my PhD, and we wrote a couple of papers on using sort of, I don't know, maybe more traditional methods in some sense. And so we found that we could actually hear a lot of the results that we found in those papers much more easily after the fact. That's not necessarily discovering anything new, but it does sort of verify that you can hear spatial relationships and temporal relationships that have physical meaning. So that's promising, I guess, as an avenue for future research. I think, however, the more useful way for this that I sort of see directly is to identify features in data sets that you don't understand. So rather than trying to use this as a means of, I guess, explaining something right off the bat, it tells you where there's something interesting.
So more exploratory, like
It's
in a
more
way.
exploratory, yeah.
Yeah.
Particularly as we move to a world where we're using machine learning, feature identification is really important, and so I think sonification could play an important role there.
Yeah. Just one quick question. Have you evaluated any of these with blind or low vision scientists or others?
Not in a formal way.
Yeah.
I think that would be a wonderful thing to do. Yep.
Right, because it's one thing for you or other sighted scientists, you look at the graphics, the visual graphics, and then you listen to the audio and you make certain relationships in your head, right? Like, oh, I can see this, I can hear that, the same thing, you know? But if you only get one of those, like the audio, you know, how well can the blind scientist identify the same features, you know, with the audio alone? I don't know. I'm very interested in that kind of question. So yeah, thanks.
Fia, go ahead.
I'd like to.
Yeah, I fully support what Amy says. I think that's one of the key things that we started off this group with. Kate initiated this, and it was all about making data accessible. So that's why the sonification was part of that effort. But I think what struck me was where you mentioned the key, where you played, you had this sample and you showed different volcanoes, what they would sound like, and then you played the sonification, and it was on a map, and we could hear different sounds of volcanoes. Although I think you couldn't pinpoint the location through the sonification, could you? You had to use the visual to know where the sound was coming from, or I don't know if I misunderstood, but I could hear different volcanoes, but I didn't get data about where they were. But I think that's an interesting part of this group project from the start, where we've been talking about how do you actually explain to the listener what they need to listen out for and what your method is, because we have no standard. Everybody's using a different method of sonification. And we have been looking at how you can really capture your sonification in an easy way and not have people having to put in a lot of effort to actually get to understand how you sonify things, because then by that time they've lost interest. So I think the idea of playing these different things and make it into some sort of key, like you would use for a map, where you have a tactile map and you say, okay, this is a mountain, this is a this is that, and then do that in ear cons, somehow come to some sort of concept about how we should approach that. Kate, maybe.
Yeah, I think that's great. Yeah, I just to follow up on the spatialization part, that yeah, I'm not sure why it didn't come through on the Zoom, but we do have a left-right panning. I think broader spatialization can be incredibly powerful. right? We're quite well adapted to hear spatially, and granted, that's not something that is necessarily easy to adapt, especially in a sort of stereo only environment, but there are modeling tools that one can use to spatialize even with stereo. So I think there's some opportunity to use that approach. And more broadly, I guess this notion of the key, that's really been, I feel like a revelation to me too, because it not only allows you to sort of realize what you're about to witness and think about it before you're asked to do something with it, but also, yeah, provides you the important contextual information. And so I by no means feel like we've figured it out, but it seems as though that's a crucial part. You also don't want to make them too long, because as you say, right, if you make the key too long and you're like, this is a volcano, this is a stratovolcano, this is a stratovolcano with andesite, this is a stratovolcano with basalt, this is a stratovolcano with rhyolite, right? Already you're bored, right? And so I think depending on the context, one has to make some choices. And so that's a real challenge, but also an opportunity.
If I can follow on with the key comments.
Yeah, we're going to take that one last comment and then we have to go on.
All right, I'll be quick. Yes, I agree with Fia and Amy. There needs to be more of a key. You might want to look at Amy's Accessible Oceans, where they took pieces apart and then put them together at the end after you'd gone through the bits of the key. And I think Zoom was distorting the spatial for me. I heard the different instruments, but they're all at the same pitch, and it was kind of a mash up. If you want to send out a link where I can listen to it without Zoom interfering, that would be handy.
Okay. It sounds like we have a lot of interest, and maybe we can, work through Slack, or if there's other interest to dive into any piece of this more deeply, we'll be able to do that in the future. So I'm just watching out for what you guys want. With that, excuse me, I would need to move on to our presentation from Sarah Lindsay from this morning, and Bruce will be here to answer questions after we're done. I am pretty sure that I managed to edit out all the glitches and add in some things that might be helpful. And so we're going to listen to that, and then we will have time for questions. So with that, I'm going to share my screen. You should be seeing the screen, Sonification World Chat, GeoSonNet, and if I can get rid of this toolbar, I can hit play. Oh, hold on, I have to stop sharing because I also forgot to hit the share audio. So let's try that again. Share audio on 2. We are going to, let's see. I thought, where did the share? Oh, share sound. You update Zoom and you lose things. Okay, there you go. Here we go. The Sonification World Chat and GeoSonNet present an introduction to the Sonification Design Canvas with Sarah Lindsay. So with that, we're going to move to Sarah Lindsay, and she was really instrumental in the success of the Audible Universe conference that we met in person in 2022 at the University of at Leiden University, the Lorentz Institute, and getting the sound people and the astronomers and a significant number of people with visual impairments together in the same room and online to explore getting a design structure behind how we think about creating sonifications. So when I first started in the area of looking at sonifications, I found there's a lot of people really interested, but it's one data person working in their study with some Python code and not thinking about the design process, or as in Bruce's expertise area is getting to the evaluation piece. So Sarah's group really helped put some structure under that, and so I'm looking forward to having you all introduced to the design canvas. So Sarah, go ahead and take it over.
Thank you, Kate. I'm flattered. I'm not sure I was critical to the success of the Audible universe, but but thank you for the introduction and thank you for having me here. Thank you, Anita, for the first part. There's a lot of overlapping, I think, between our two presentations and the way it ended, particularly about how do we make choices when we start to a new sonification project. So what I will present is about that. And I'll share. So the data sonification canvas is a tool for sonification design. I'll get to what a tool for designers is before you think that it's any fancy digital or interactive application. Is basically a piece of paper, either a literal piece of paper or a digital piece of paper. So the real critical part of being a tool is in what it says in the contents, but a very quick overview where does the canvas come from. Anita already, thank you for that, introduced the Data Sonification Archive. So the canvas is part of a bigger project that dates back to my PhD research and the work we've been doing at the Density Design Lab in Politecnico di Milano, which is an information design lab, a data visualization lab, where I had the pleasure to introduce sound. So when I was there, we started this project of the Data Sonification Archive. That basically started with me collecting a few cases, a few sonification projects, and see how I could look into that to gather relevant information to inform my projects. So selfish endeavor. I start collecting disparate. The goal was to map the sonification world. Who is doing sonification? Why? Where? And then another one of these fancy diagrams, but basically what Anita showed earlier, where we used also in the review paper in the review study for sonification for astronomy, is the way that we at the Data Sonification Archive classify projects. This has been an iterative process, and at the moment we are using these categories, and now we just we are in the process of launching a new version of the archive where you will be able to search using this classification, which is the one we use when we curate new projects. So we analyze existing sonification projects by their intended goal. So why was this sonification done? Is it an artwork? Was it accessibility? I mean, Anita went through these categories, so I will skip, but we can go back. And of course, you will have this presentation later. Other questions we ask ourselves: who are the intended users? What sonification method was used? The community, the sonification community over the decades agreed on certain methods that are codified and are defined, like parameter mapping, audification. What is the media mix? Another thing that Anita already showed. And then, of course, we classify them by... We currently classify the new projects. We classify the existing projects on the archive. So it's not a coincidence that this classification was also in Anita's diagram, but I will not go through it too much unless you can ask me any questions you have later. So we classify by their intended goal, as mentioned by Anita. Is it an artwork? Is it accessibility? Is it for real-time monitoring? By their intended users, domain expert, general public, by the method, the sonification method they used. The sonification community has defined several methods that are accepted and have their own definition and scientific literature, like audification, parameter mapping, and then, of course, media mix. We talked about it already, and the micro topic. So you heard me say intended goal, intended audience. So in the design world, be it, product design or experience design or service design, what designers say is that a prerequisite is the why we are doing that and the impact you want to have on the real world. We define this as intentionality in design. It is basically all those decisions that we make when we design something, we create something, and we are asking ourselves, what do I want to communicate with this? What is the real world problem or phenomena, in our case, I want to represent, and for whom? that's really quick. The intention of this slide, the intentionality of this slide is really to show the other piece of information that we used to define the canvas. That was basically, why are people designing, doing sonification? And we created this, we defined a continuum where we analyzed existing cases, and we said some of these cases are better at communicating, are more successful in that sense, and some other of these successful meaning they use the right metaphors that we discussed with Anita, color blue, water bubbles, or they use the right medium, or they use the right combination of sensory modalities. And some others, perhaps they are not so successful, but not because they are badly designed, rather that because the authors perhaps didn't ask themselves these questions: why and how am I doing that? The last piece of information was my work with authors of sonifications that I interviewed at length to come out really with what mattered to them, what were the critical decisional points they were using to create a new sonification. And from all that, we said, okay, we have now all this information. How do we put it together in a tool that can be useful, that can be replicable in other contexts and by other people? And we decided to instantiate this research in a design canvas. This is what a design canvas looks like. There are for many things, designing new businesses or products. It all goes back to what was successfully commercialized as the design thinking method, but it really comes from a design research and the reflection of what it means to be a designer.
On slide 6, Sarah is giving an example of a rather complex design canvas that is used in her field that provided the starting point for her work for the design canvas for Audible Universe. It has many sections. She is just using this as an example.
It all goes back to what was successfully commercialized as the design thinking method, but it really comes from a design research and the reflection of what it means to be a designer, where versus being an engineer or being an artist. What makes design unique? In the lab where I was, we already used something called the visualization canvas. And then we mimic, in a way, we borrowed that format to come up with what is today the data sonification canvas, which is this rectangular piece of paper defined by 4 building blocks. So I will go into each of these building blocks, but the idea of the canvas was really to provide a self-reflection tool, something that anyone, regardless of their expertise in sound or expertise with data, if they wanted to integrate sound in any information representation project, specifically data sonification project in this case,
here.
Yeah, I'll also mention one of the things that was useful about the canvas, because I was part of that online group at that symposia. What also helped, what Kate was saying, we had a chance to work with an existing sonification and study it using the canvas, and then we got to work with a team. But again, it was that idea of a multidisciplinary team. So we were doing self-reflection, but we were also engaging in the communication and learning how our languages are very different as well, even using the same terminology. So I think.
Yeah, so I think we are ready for the next slide, because then we start getting a bit more into the content.
Okay.
As I said,
right. Hold on, there we go.
Yeah. So the canvas, the current version, because we have a new version in preparation, there are limits to this format that I will go through later, hopefully, unless it's the room. So the first block really asks you to define your use case. We found, talking to experts, authors of sonification, and through the work at the archive, that not everybody asked themselves really, who will be my listeners? What are the goals of what I'm doing, and what is the context of the sonification? Maybe we can already Kate, go to the next one that is about the first block. Yep, and then next. Yep, so the parts of the first use case block are visually split in users, goals, context. And what really we are trying to stimulate someone that is starting a sonification project is to ask herself or himself questions such as, who will at the end listen to this? So do they have any stake? Are they stakeholder in a specific process? So if we are doing sonification for astronomers, are our final listeners astronomers or non-astronomers? Or is it a political issue or a social issue that we are trying to represent? And then do these people that will listen to it have a specific opinion about it? Are we trying to convince them that they are wrong or reinforce that they are right? I mean, even the ethical responsibility when we do something like that, because we are communicating something, whether we want it or not. In fact, the new version of the canvas will have another block that is called consequences. So is what we are doing, these new sounds we are introducing, are they meaningful? Are they sustainable in the broader picture? You know, it really asks you to think about that and take your decisions accordingly. And it is meant to be an iterative process. So the whole idea of also having this piece of paper is to fill in one, and then a second one, and then a third one, and then go back to the first one and see how the project has changed. Is really also to help you document your reflection process. The goals, ideas of questions, we put in ideas, and then it really depends on the specificities of your project. But it's really your goal as an author, your goal as a sonifier. Are you addressing specific needs? And what are these specific needs? The idea is that you try to be as specific as you can here. And this will really greatly help you along the way. At least this is the hope. We can move, Kate. Sorry, I have to ask you that. And the context, those ideas of questions for the context. This is the context of experiencing the sonification when it will be released and published. Is it an online, is it an interactive web page, or is it a physical installation in a physical space? Are listeners using headphones, for instance? This greatly changes the decisions you will take along the way. Cultural connotations is also a perhaps underexplored area of reflection in sonification, but are the sounds I'm using like universally understandable? Or maybe they aren't, because this is not the goal of my project. And we can go to another block. This is a bit more technical. Thank you. So this is really about the specificities of data sonification. So it really asks you to reflect on your raw material, your tools, your rules that you will apply to the project. So what are the sounds you are going to use? Behavior stands for how does sound change over time depending on changes in the data set? What is its semantic function? This we are starting getting a bit into technicalities. And then is it combined with other modalities, as Anita discussed earlier? So next slide, please, Kate. Types of sounds. Here, really, the idea was to, again, stimulate a reflection on choosing your sounds. Many times, the choices of what types of sound we use in a sonification might be dictated by the tools we have and how skilled we are in sound design. If we aren't, and we use a program that gives us MIDI piano sounds, then we most likely will go for MIDI piano sounds, regardless of whether they are the most appropriate. So there might be contingent decisions. Even so, it's good that we are aware of that. And perhaps we think of reaching out to a friend that is a sound designer and expanding the team, as Anita was saying, because of course we are not expected to be experts in everything. So are the choices of sounds we are making limited by our skills or our technologies? And if we could instead have whatever we want, then what will these sounds sound like? A behavior is about the rules that link changes in the data sets to changes in the sounds, the so-called mapping rules. Are we leveraging psychoacoustics, for instance, as in Anita's research? Or are we using instead embodied metaphors? It's another framework. So this refers to what really controls how sound changes. Bruce could talk about one of his most famous, perhaps, experiments with visually impaired users, listeners, sighted and blind listeners who interpreted the mapping metaphors completely opposite ways. So again, what is the criteria that we use when we establish these rules? Functions comes from the world of semiotics. So back when we worked on the canvas, we also had several workshops with information designers who came from the design field, strictly speaking. So they also had a training in semiotics. And at that time, it seemed like a good idea to reflect on this. It turns out to be a bit, technical, complex to gauge by people that are not trained either in philosophy or communication sciences. So we might remove it. But anyway, is the idea to reflect on how connected is this sound that we are using with the real world phenomenon that it stands for. With the idea that this would guide or give you ideas again on choices that you may want to make. So are you opting for straightforward causal connection, like we represent rainfalls and we use the sound of rain? Do we want to do that? So literal, it might be appropriate for a specific context or for a specific audience. Or instead, do we want to use sounds as auditory icons? Is it an icon of something that is real? Like we use a sound of throwing paper, the famous Apple sound that has been discontinued, right? We are crushing a piece of paper to represent the bin. Or is it really arbitrary, as it might happen with musical sounds, with the trumpet? I decide I go for the trumpet because it's an homage to my past. That's perfectly legit. Just the more you are aware, the more your audience will be, most likely. And then what are the other modalities you combine sonification with, if any? And we can go to the next. Okay, thank you. Yep. And then so what we called back then sonification approach. This is really about overarching intentions. And this is borrowed from visualization, where some authors proposed a framework where there's a big overarching polarity in data visualization from a design perspective, where you are asked to decide to position your work in this continuum between an analytical intention, where you really need your audience to understand hard values in a data set, maybe because they have to take decisions based on that, maybe because they are operators in a control room, so they have tasks associated with understanding specific data values. Or is your intention narrative? Are you telling a story to engage the general public? Another thing that Anita was saying earlier, right? These are very broad, generic distinctions, but they bring about a lot of other secondary decisions. So they are critical. And we can go to and of course, this could change. Yeah, this was an example. It could change even over the course of the project. So it's something that we say, ask yourself when you start, and then you might change your idea as you go. And it's also good to go back and see how the perspective has changed and what is the relative weight of an analytical versus a narrative approach. And the last block, thank you, Kate. It's about, this is borrowed from sound design for films theory, the actually from Michel Chion's work that also borrows from Pierre Schaeffer, perhaps the father of electroacoustic music, and his definition of the audience listening experience when we hear electronic sounds that are somehow disconnected from the real world. We don't see a musician making a gesture that results in a sound. This disconnection requires an additional attentive listening, as Anita was saying again. Thank you, Anita, for all these inputs. And Michel Chion defines 3 different listening attitudes that we as designers, as composers, need to imagine, because then the sound we make, the sonification we make, should have this expectation embedded already. Causal is like listening attitude, a listening experience that we have in everyday life. We tend to have, when we hear a sound, we tend to connect the sound with the source that produced it. Again, rain, oh, it's raining. Dogs bark, there is a dog. This is the causal connection. So if we use in a sonification barking sounds, most likely people will think of dogs. If we don't want them to think of dogs, maybe we should opt for a different sound or provide more context or make other decisions. The semantic listening attitude is where we need a code to understand the sound. Music, Western classical music, sonata form, it has a specific code, it has a specific grammar. If understanding this grammar is part of what we expect our listeners to do, then we need to be ready to provide enough information. And reduced, finally, is something that typically sound designers or sound artists would do, which is listen to the sound, to the pure sound, to its acoustic components, the change in pitch, the timbre of the sound. So really we focus on the sound abstracted from external meanings. This is quite typical, I would say, in digital sound. So we are listening to understand, for instance, is it this sound clean enough? Is it clear that the pitch shifts and etc.? So this is very specific from electroacoustic music. And again, we put it there at the beginning thinking that it was an interesting input. It might be a bit difficult to understand. Even so, it is something that we do in sonification, like in the examples of Anita, when we ask our listeners to focus on the change of pitch, regardless of whether this is a piano sound or it's a human voice. Just focus on how the frequency changes. This is reduced listening. If we don't want our listeners to do that, then we need to change the type of sound or change the way we describe our work. We can move, Kate, because this is what I just said. This is just quickly, if you are more interested more than what I can say today, there is a paper where we described the first mini evaluation study that we conducted. We asked 50 participants and about half came back. We used an existing format for evaluating digital experiences, digital products. It's called attractive. It measures the pragmatic quality, which is this product doing what you intended to do? And then the hedonic qualities, which is, does it also appears to its users? HQ is hedonic quality I in the graph diagram at the right, which stands for identification. So do I really feel that this tool is something I want to use? Does it fit with my life and my values? And the other is S stands for motivation, which doesn't start with S. There's another word that I don't remember now, which, how is it defined? Stimulation, I think. But anyway, it's defined as, how motivated you are in using this tool. for your work. And we performed quite well. Interestingly, the summary of all the variables that are used in Attractive, which is at the left side, said that is a self-oriented tool, which we were quite pleased about because this is really how we designed, how we imagined the canvas. And there are other data, but I don't think is relevant. I mean, I didn't put them in the presentation, so Kate, we can move to the other one, because also with some of these participants, a good chunk, like 10 people came back also with additional feedback, and we had conversations with them. All these people that participated were users of the canvas, had used it at least once, but usually more than once in the past previous 12 months. So they did confirm that it was a useful tool for self-reflection during the entire process. So from the inception of the project, where you can also start to categorize the same way we do in the archive, categorize existing projects to gather ideas. But then overall, the entire project to support the decisional process. And if you are working in a larger team, or if you have a specific client, you can also use it to establish a common language, which is also critical in a field like that, that is, let's say, it involves often people with different backgrounds. But then areas to improve, I think they are very relevant for us, because the format, it's a PDF, it's not accessible, it's very the accessibility features are very limited. We used it in the Audible universe on a PowerPoint. In fact, there was more accessible. We are thinking of implementing a new version online, but that would make this specific aspect easier. So any advice on this will be very welcome, because other critical annotations were that of course, the description of some blocks are too technical, so we are revisiting that. And the language, you can't embed multimedia content on a PDF, on a printed piece of paper. That's why we thought of platforms like Canvas or Miro, but those are even worse than PDF for accessibility, as far as I know. And then, of course, there is the rectangular shape, there is this order, but this reflects our order. So we should provide a format where people can move around the blocks and deconstruct them as they wish. So we are working on that. Any help, more than welcome.
So I am going to stop there, because we're at the end of the presentation and we had quite a few really good questions, but I want to take advantage of Bruce's perspective and expertise here and open it up to questions from this group. And you're welcome to, when I get this posted, go back and look at the questions that were asked from the previous group. So if you want to, just go ahead and unmute. There was a lot there. So Bruce, would you like to start by telling your quintessential story about sighted people flipping their parameter map mentally from people with vision impairments?
Sure, that's a fun one. So, 1,000 years ago when I was doing my dissertation, back when I had hair, one of the key things we were trying to figure out is, how do you take data and represent it with sound, right? And what should this mapping be like between the data dimensions, like price or temperature or velocity, and sound parameters like pitch or tempo or loudness or what have you. And we did a bunch of studies involving sighted and blind and low vision participants. So we have this pretty traditional mapping of, say, dollars onto pitch. So bum, 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 bum. As the pitch goes up, am I getting richer or am I getting poorer? And so we ask a bunch of sighted undergraduates that question, and they all say bum, 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 bum. As you get higher in pitch, you're getting richer, more money, more higher pitch, more money. This didn't surprise anybody. And so then we did the same study with blind participants, getting richer or poorer. They said poorer. They said higher pitch is less money. And at first we were like, what? And then, you simply ask why. And they say, well, more money is more coins, is more potatoes, is more elephant. Anything more is bigger, and bigger things make lower pitch sounds, right? You've got a violin, and then you've got a cello, and then you've got a bass. And so they perceive this as a very physical way. So they gave examples like, if I took a coin and I dropped it on the table, it would go plink. If I took a roll of coins and put it on and dropped it on the table, it would go plunk. And if I took a bag of coins and I dropped it on the table, it would go thud, right? So they have a very physical, the participants in our study had a very physical perspective on how sounds could represent data. And we found a number of these kinds of mismatches, these incongruities between the way sighted listeners perceive things and the way the blind and low vision listeners perceived things. Then you have all kinds of follow-on questions like, who's right? And is that even a sensible question? If you have a classroom and you have 25 sighted students and one blind student, what do you do? So we started to look into all of those kinds of things. I'll leave it there, but it's important to understanding your audience and their mental model of the way sounds could or should represent numbers and data. It turns out that most sighted listeners don't really have a systematic way of listening to the sounds. And so they go with a default where they lean on their Cartesian graphing information, where up, that is the distance away from the x-axis in a typical XY plot, up means more in many cases, not always. So they just lean on this sort of default that up in space or up in the page or up in pitch must mean more. We did interesting studies after that to see whether we could change their minds, and absolutely, right? So you can say, no, think about it this other way, and they immediately can recode it and understand it. So I think those are some of the considerations that Sarah brings out once you've decided that you're going to use, say, pitch to represent dollars, then you've got to figure out the subtleties of how to actually do the design and figure out what your listeners are going to understand. So it comes back to the sort of intentionality and understanding, know your users kind of thing.
Yeah, Bruce, do you happen to know on the slide where they were looking at high intentionality and low intentionality, they had a number of projects placed on that line. How did they measure how well you did on being intentional? I didn't catch that.
Yeah, I think that was a bit of a placeholder slide intended to just kind of make the point that the level of intentionality in a design can vary. And sometimes you are trying to have an impact, and sometimes you're just trying to make sounds. And sometimes the impact is enjoyment, and sometimes it's some understanding, So I don't know that I could really decode that graphic very well.
That's okay. That's okay. It does make me think too about, then knowing what your level of intentionality is and being able to evaluate that goes straight into the evaluation piece of your process. And very few people right now are doing, evaluations on their sonifications, or it's growing.
Yeah, and thank you, Aura, for for posting the link to that paper where all questions are answered, I think.
Okay, thank you.
But to your point, Kate, absolutely. I've been on the evaluate this bandwagon for 25 years. And one of the things that is immediately apparent is that you have to be intentional and you have to understand all of the different parts of a graph, for example, right? So if I just drew a line on a page and I handed that in for my 10th grade homework and said, here's my graph, I would fail, right? The teacher would say, well, that's not a graph, that's just a squiggle on the page. It's not a graph until you've got an x-axis and a y-axis and tick marks and labels and all of that stuff, all the context that takes your squiggle on the page and turns it into a graph. And if you think about the same analogy for sonification or auditory graphs, you need all the same stuff, right? Ways to the key, the legend, the context, the tick marks, the axes, trend, all of it. And you can hear me say that, but when you start to evaluate something with real users and they listen to it and you're asking them, so what's the temperature at this particular date? You're like, what? Right? It starts to hit home very quickly once you do evaluate things. And once you are not just saying, well, it sounded good to me. So.
Yes, and that's one of associated with my soapbox, that if we are going to create sonifications that communicate information from graphs and aren't necessarily the purpose of the sonification isn't to do data analysis, but to understand data, the sonification has a lot of advantages over, say, just creating alt text for an image, because you're allowing those person without vision to interpret the graph themselves and to come to their own conclusions, whereas so many other accessibility features that we try and slap in, and we do the best we can, we do the interpretation, and that's taking away agency from a whole group of people. So I think, and wherever we can, we have to be intentional and always include the BVI user in our design process.
I think that whole notion of autonomy is super critical. We ran into that, and I'm sure many on this call would resonate with this. When we're trying to make middle school and high school mathematics tests and homework accessible to blind and low vision students, if the question says, look at this graph, and the graph has some data on it, it's an X and a Y plot, is the slope going positive or negative? And the students have to look at it and understand what slope means and interpret the visual graph. If you use sort of alt text or an image description and you say, here's a graph and the line slopes from the bottom left to the top right, you've described it in such a way that you've given the answer. So that's not an equitable, it may be accessible, but it's not an equitable component in the education. So there's, if you just let them engage with the data in an accessible graph format, then they would have to come to that understanding on their own and answer the question autonomously. Okay.
Well, I'm going to start letting people drop off the call. I will leave this open for a few minutes if we want to continue to just say aye or whatever, ask some questions. Otherwise, we're going to stop the recording, and thank you all for just enduring my editing job of Sarah's recording that got dropped about 3 or 4 times this morning.